Hello everyone. In this video, we are going to discuss about filling of orbitals in atom. We will be discussing about Aufbau principle, Pauli exclusion principle and Hund's rule for maximum multiplicity from the chapter 2 structure of atom class 11 chemistry. So you see, the filling of electrons into the orbitals of different atoms takes place according to the Aufbau principle, which is based on the Pauli's exclusion principle, the Hund's rule of maximum multiplicity and the relative energies of the orbitals. So let us first talk about the Aufbau principle. See, the word Aufbau, it is actually a German word which means building up. See, building up of orbitals means filling up of orbitals with electrons. See, the Aufbau principle helps predict the electron configuration of atoms, which determines their chemical properties and behavior. According to Aufbau principle, the principle states that in the ground state of the atoms, the orbitals are filled in order of their increasing energies. That is, electrons first occupy the lowest energy orbital available to them, and after filling the lower energy orbitals, they enter into higher energy orbitals. See, the order of energies of the orbitals can be remembered by using this method. That is, you see, I have just written this 1s, 2s, 3s, 4s, 5s, 6s, 7s, etc. here. Then next column we have 2p, 3p, 4p, 5p, 1p, 7p like that, because we don't have 1p. Then we have 3d, 4d, 5d, 6d, etc. See, we don't have 1d and 2d. Then we have 4f, 5f, then 6f like that. Okay, because we don't have 1f, 2f, 3f. We don't have that. So we started with 4. Now after writing this, we have to start from the top. Okay, see the direction of arrows, that actually gives the order of the filling of orbitals. That is, start from the right top to bottom left. Okay, start from the right top to bottom left. Okay, so here you see the order of energies will be in this way. First we have 1s. That is 1s orbital to be filled first. Okay, then the next energy level will be 2s. Then 2p, 3s. 2p, 3s. Okay, then 3p, 4s. 3p, 4s. Then 3d, 4p. Okay, 3d. Start from the right top. Okay, then to the bottom left. So 3d, 4p, 5s. 3d, 4p, 5s, then 4d, 5p, 6s. 4d, 5p, 6x. Okay, like that. Okay, then 4f, 5d, like that. Okay, so this is the order of energies. So you see, this order is assumed to be rough guide to the filling of energy levels. See, 1s orbital is the lowest one, so that should be filled first with the electrons. Then after that, the leftover electrons will go to the 2s energy level. After that, the another electrons will go to the 2p energy level, like that. See, we will be discussing some examples to get a clear idea about this Aufbau principle at the end of this video. So please watch that as well. Okay. So next we are going to discuss about Pauli exclusion principle. See, Pauli exclusion principle. This principle was formulated by Austrian physicist Wolfgang Pauli. See, it helps in calculating the capacity of electrons to be present in any subshell. See, according to this Pauli exclusion principle, no two electrons in an atom can have the same set of 4 quantum numbers. 4 quantum numbers are principal quantum number, azimuthal quantum number, orbital magnetic quantum number, then spin quantum number. Only 2 electrons may exist in the same orbitals, and these electrons must have opposite spin. That is, 2 electrons can have the same value of 3 quantum numbers N, L and Ml, but they must have opposite spin quantum number Ms. See, the maximum number of electrons in the shell means K, L, M and shells, with the principal quantum number N will be equal to 2n square. So you see, what about the maximum number of And similarly, you see the maximum number of electrons in a subshell. Subshell means S subshell, P subshell, D, F, S, P, D, F. So, the maximum number of electrons in a subshell that can be calculated by using the formula 4L plus 2. So, you see, if you consider the S subshell, for S subshell, we know that the L value is 0. So, maximum number of electrons in the F subshell will be equal to 4L plus 2, that is 4 into 0 plus 2, which is equal to 2. So, maximum 2 electrons can be accommodated in the S subshell. Okay, then next we have P subshell, L is equal to 1. Okay, then the maximum number of electrons that can be in the P subshell will be equal to what? 4 into 1 plus 2, which is 4 plus 2, 6. Okay, similarly, if you consider the D subshell, L value is 2. So, maximum number of electrons that can be accommodated in the D subshell will be equal to 4 into 2 plus 2, which is 8 plus 2, 10. Similarly, if you consider the F subshell, L value is 3, which I have already discussed in our previous video. So, maximum number of electrons in the F subshell will be equal to 4 into 3 plus 2, which is 14. Okay. Next, let us discuss about Hund's rule of maximum multiplicity. See, this rule deals with the filling of electrons into the orbitals belonging to the same subshell. That is, if you consider P subshell, it has 3 orbitals, Px, Py and Pz. These 3 orbitals are of equal energies. That is, all these 3 orbitals are degenerate orbitals. So, Hund's rule of maximum multiplicity that deals with the filling of electrons into the orbitals belonging to the same subshell. That is, if electrons are there to fill into these orbitals, the P subshell, it has to fill the Px first, then Py shell first, then after that Pz only. Because you see Px, Py and Pz, they have equal energies. All the 3 are degenerate orbitals. So, Hund's rule of maximum multiplicity gives an idea about how the electrons to be filled in degenerate orbitals. See, Hund's rule of maximum multiplicity, it actually states that the pairing of electrons in the orbitals belonging to the same subshell does not take place until each orbital belonging to that subshell has got 1 electron each and it is singly occupied. That is, the orbitals of a given subshell are first filled singly and then the pairing of electrons in each orbital begins. That is, electrons first fill up singly, then only start to pair up. It means orbitals, atomic orbitals, tend to have more unpaired electrons as far as possible. A greater number of unpaired electrons offer maximum multiplicity. That is why Hund's rule is called as a rule of maximum multiplicity. Let us see one example. Let us consider an example of filling electrons in a nitrogen atom. See, for a nitrogen atom, its atomic number is 7. So, its electronic configuration, see, as per the Aufbau principle, the electronic configuration can be written as, you see, as per the Aufbau principle as well as Pauli exclusion principle. You see, as per the Aufbau principle, the order of energies of the orbitals are like 1s, 2s, 2p, okay, then 3s, 3p, 4s, 3d, etc. According to Aufbau principle, we have this, order of energies of the orbitals. Now, according to Pauli exclusion principle, what? No 2 electrons, you see, no 2 electrons in an atom can have the same set of 4 quantum numbers. That is, they must have at least the opposite spin quantum number when they are, filling, when the electrons are filling the orbitals. So, here you see, if you consider the electronic configuration of the nitrogen atom, see, maximum number of electrons that can be in the F subshell is 2. Here we have 7 electrons. So, 1s2, 2s2. Because S subshell can have 2 electrons maximum. Next, we have, so 2, 2, 4. But we have 7 here. So, 3 more. So, P subshell can have maximum 6 electrons. So here we have 2, 2, then this will be 2. Sorry, this is 7, no? So 3. P subshell can have maximum 6 electrons in it. So here we can write 1s2, 2s2, 2p3 as the electronic configuration of nitrogen, because you see S subshell can have a maximum 2, another S subshell that can also have maximum 2, P subshell can have maximum 6, but here we have only 3 electrons here. So 1s2, 2s2, 2p3, this is the electronic configuration of nitrogen atom. So you see 2 plus 2, 4, 4 plus 3, 7. Okay, now I am going to draw the orbital diagram of this nitrogen atom. You see, there are 2 electrons in the 1s orbital. Okay, so 2 electrons in the 1s orbital. You see, 2 electrons in the 1s orbital means spin up and spin down, because the fourth quantum number must be different. Okay, so spin up and spin down. So what happens? 1s orbital has 2 electrons. So one should be spin up, another one should be of spin down. Okay, according to the Aufbau principle, according to the Pauli exclusion principle, it should be like that. Now the third electron of the nitrogen atom, it is not allowed in the 1s orbital. So the third electron in nitrogen atom, it is not allowed in the 1s orbital because of Pauli exclusion principle. So it will take the next available choice, that is 2s orbital. This 2s orbital can accommodate 2 electrons. So one spin up, one spin down. Okay, so 1s2, 2s2. Now 2p3. See, 4 electrons have accommodated in 1s and 2s levels. Now you see we have 3 more electrons. The 5th electron goes to the next level or orbital. See, next level or next orbital is p orbital. See, this p subshell can accommodate maximum 6 electrons, but only 3 electrons are here. P subshell has 3 orbitals, px, py and pz. So here we are considering 2p. So 2px, 2py, 2pz. See, all the 3 orbitals, 2px, 2py and 2pz, they have the same energy. That is, they are degenerate orbitals. So you see, according to Hund's rule, when electrons have a choice of orbitals with the same energy, they will occupy the orbitals singly. That is, 1 electron per orbital before pairing up. So you see we have 3 orbitals here. So 1 electron in the first one, 1 electron in the second one and 1 electron in the third one. Okay, so orbital picture of nitrogen will be like this. Now let us consider the case of oxygen atom. Its atomic number is 8. Okay, so you see its electronic configuration will be 1s2, 2s2, then 2p4. Okay, because 2 plus 2, 4, 4 plus 4, 8. Okay, so you see the 2 electrons will be in the 1s orbital. So 1 spin up, 1 spin down. 2 electrons in the 2s orbital. So 1 spin up and 1 spin down. Then 4 electrons in the 2p orbital. Okay. So you see p subshell or p orbital can accommodate maximum 6 electrons. Here we have 4 electrons. See, all the 3 orbitals px, py and pz, they have the same energy. So according to Hund's rule, when electrons have a choice of orbitals with the same energy, they will occupy the orbital singly. That is 1 electron per orbital before pairing up. So 3 electrons, 1 electron in the px orbital, 1 electron in the py, then 1 electron in the pz. Now we have 1 more electron. So that will occupy in the px orbital like this. Okay, once they singly occupied, they start pairing up. So you see, this is the orbital structure of or orbital picture of oxygen atom. So in this video, we have discussed about the Aufbau principle, Pauli exclusion principle and Hund's rule of maximum multiplicity. I hope it is clear to you. So in our next videos, we will be discussing about all other topics from this chapter. We will be discussing the electronic configuration of atoms and all other topics in this chapter, which will be available in the playlist. Thank you.